Welcome back to Fundamentals of Mechanical Design. Today we're going to pick up where we left off last time and look at what Shigley's has to tell us about what the rest of the mechanical design landscape looks like from an engineer's perspective. All right, so picking up right where we left off yesterday with the mechanical design process, let's go ahead and now consider what the rest of this chapter looks like according to Shigley's. I've gone ahead and highlighted what I think are the most important aspects for us to understand. And you can see that yesterday we really went over this kind of fundamental idea of design. What is it? That invention, when the value happens, difference between design requirements and design specifications. There's a really amazing case study at the end, actually. And although the example doesn't really provide the full list of specifications here up on the board, it does give you a feel for the difference in the engineering work and the customer development and product specification work. Now, when we start to think about sort of this section right here, where we've got tools, resources, and responsibilities, we're talking about lots of different safety standards and codes that we have to follow, codes of laws for things, and standardization that, standardization, as much of a pain as it might feel like sometimes, it's actually a huge enabler of economic value creation because it's much easier to lower the cost of standardized goods. So, all of this stuff is a bit, very high level in scope. And it certainly affects the design engineer in various multitudinous ways. But there's also reason to kind of safely set it to the side for our purposes in this series on principles, because while they are fundamental principles for a design engineer, these sort of intangibles of doing the job, what we're focusing on in this series are the product-facing analyses, tools, tips, and understanding of the part being designed, rather than on the implications of that part being designed all the way out throughout the entire world. So that's why, Shigley's just briefly touches on it in chapter 1, and that's why it's worth just briefly touching it on it, here in our series as well. So, with that being said, the real next focus is to understand stress, to understand strength, to understand failure, and to understand how statistically we need to estimate how strong things are, when they're going to fail, how reliable they're going to be, using a variety of, you might call them fudge factors, but also mixed with sort of a rigorous statistical approach. So we use our intuition to fudge a little bit. We inform that implementation of our intuition with rigorous statistics, and then we test it out until we make sure that our designs are safe, good to go, ready to roll, ready to be put into production at scale. And then the chapter really wraps up then with talking about dimensioning and tolerances. And this is sort of the symbology, if you will. It's the language of engineering drawings, of creating exact specifications for part geometry. And then units are, of course, very important when we're designing things. You don't want to, screw that up. Obviously, there are many examples. And then lastly, there's some problems in the book that sort of follow the text throughout in different chapters. And so that's sort of just to demonstrate that design has interdependencies depending on the analysis you're doing at any given moment. So that's really the rest of the chapter. And so if we kind of look in totality, the design process aspect, I really chose to focus on here. What we're going to pick up with next video is we're going to pick up with stress and strength and dive a little bit into uncertainty and failure.